Let's be honest. Have you ever stared at a Carnot map, circled a few groups, and then just kind of hoped you found the simplest solution? Well, today we're going to ditch that guesswork. We're going to walk through a clear, step-by-step method that will absolutely guarantee you master K-Map simplification.
So here's our game plan. First, we'll talk about the K-Map challenge itself. Then we'll get our vocabulary straight so we're all on the same page. After that, we'll dive into a really powerful 6-step algorithm, see it in action with a real example, and then use it to find that perfect minimum cover. Let's jump right in.
In Boolean algebra, Carnot maps serve a highly specific function. They allow engineers to easily spot adjacent ones, where only one variable differs, and combine them. However, this basic method relies heavily on human visual intuition. We are essentially just eyeballing the grid. Relying on visual groupings makes it extremely difficult to verify that you have found every possible cover. The larger the map, the higher the probability of missing an optimal grouping. To guarantee the absolute minimal literals per product term, we must abandon visual guesswork in favor of a systematic, step-by-step deductive algorithm. Before executing this algorithm, we need a precise vocabulary. We start with the onset. This is the exact set of input combinations that produce a true output for a function, represented on our map by ones. Next is the DC set, or don't care set. These are input combinations that can be either true or false without affecting the overall output. When we group these cells, we create an implicant. An implicant, or cover, is any valid combination of one or more min-terms from the onset and the DC set. If we expand that implicant to its absolute maximum allowed size, so it cannot be combined further, it becomes a prime implicant. The primary objective of logic simplification is twofold. First, grow basic implicants into prime implicants to minimize literals. Then, cover the entire onset, using as few of these prime implicants as possible. This diagram shows the visual distinction between these two terms. The smaller orange group is just an implicant, while the maximized green group is a prime implicant.
And now for the most important term of all, the essential prime implicant, or EPI. So what makes a PI essential? Well, it's the only one that can cover a particular one on the map. This makes it a totally non-negotiable part of our solution. Every single EPI must be in our final answer, no exceptions. Here's a perfect example. Check out the one in minterm 10. The green group, which represents the term AC, is the only prime implicant that covers it. If we don't include AC, that minterm 10 is left all alone. That's what makes AC an essential prime implicant. Now look at this map. This is a totally different situation. Here, each of those 4 yellow groups covers a one that no other group can touch. That makes all 4 of them essential prime implicants, which means our final answer is simply adding all 4 of them together. Okay, so we've got the vocabulary locked in. Now we are ready for the heart of this explainer, the 6-step algorithm. Think of this as your foolproof roadmap that's going to put all those terms into practice. So here's the game plan. Step 1, fill the map. Easy enough. Step 2, scan for the first uncovered one. Step 3, find all the prime implicants that cover that one. Step 4, just rinse and repeat that for all the ones. Step 5, identify your essential prime implicants, the must-haves. And finally, step 6, cover whatever is left over with the fewest PIs possible. Now let's actually see this in action. All right, enough talk. It's time to put this algorithm to work. We're going to apply our 6-step method to this 4-variable function right here and see exactly how it all plays out. Step 1 is pretty straightforward. We just take our function with its onset minterms and its don't care minterms, and we plop them onto the K-map. Remember, the ones are our main targets, and the x's, they're like little helpers we can use to make our groups even bigger. Okay, on to steps 2 and 3. We scan the map, and the first uncovered one we find is right there at minterm 4. Now we've got to find the prime implicants that cover it. We've got 2, that horizontal group of 4, which simplifies down to A prime B, and that cool vertical orange group, which gives us A prime, C prime, D prime. Now for step 4, we just keep on scanning. The next uncovered one we hit is at minterm 13. And guess what? This one also has 2 prime implicants covering it. That block of 4 right in the middle, which is BD, and the vertical column, which is AC prime D. We're going to repeat step 4 one last time. The final uncovered one is sitting at minterm 8. And from this one little cell, we actually find 3 more prime implicants. There's the vertical wraparound group, B prime, C prime, D prime, the horizontal group of 2, A, B prime, C prime, and the horizontal wraparound group, AB prime D prime. Okay, all our PIs are now on the table.
We've done all the heavy lifting. We've identified every single possible prime implicant. Now for the payoff, finding the minimum cover and putting together our final, beautifully simplified expression. And this brings us to step 5, finding the essentials. We've got to play detective here. If you look closely, you'll see that the one at midterm 6 is only covered by that prime implicant A prime B. That makes it essential. And similarly, midterm 10 is only covered by A B prime D prime. So boom, we have 2 EPIs that we know for sure have to be in our final solution. So here's the crucial last step. After we've selected our 2 essential PIs, what's left? Well, we still have 2 ones uncovered at midterms 9 and 13. So for our final step, we just need to pick the smallest number of PIs to cover them. And in this case, 1 prime implicant, AC prime E, does the job perfectly.
And there you have it. This is our final answer. By combining our 2 essential prime implicants with that 1 extra PI we needed, we get our final simplified expression. F equals A prime B plus A B prime D prime plus A C prime D. That is a guaranteed minimum solution with absolutely zero guesswork.
Thanks for watching. See you next time.